Okay. So yesterday, nag-continue ta with our lessons sa colligative properties, right? Um, Pinagpatuloy natin yung boiling point elevation na problem solving, and then after that, we had the freezing point depression. So we stopped sa osmotic pressure, but I was not able to discuss how are we going to compute for the osmotic pressure. I guess we ended here yesterday. So let's continue. But before that, let's have a little review first about the colligative properties since na-complete ko na siya, yung apat. Di ba, we started with the vapor pressure lowering. I hope you can remember that, na if we add solute sa ating solution, that means that the vapor pressure will be lowered and consequently, the solution will not easily evaporate. And then second, we have our boiling point elevation, wherein the addition of the solute can increase the boiling point ng ating solution, meaning matagal na siya mag-boil kasi it will take higher temperature before the atmospheric pressure and the vapor pressure na mag-equal. Okay, and then the third one, we have the freezing point depression, wherein the addition of the solute can decrease. Okay, decrease the freezing point of a solution. So in the case of the ice, if you add solute, for example, the asin or the salt, ice will easily melt because the freezing point is depressed. And then the last one, we have the osmotic pressure. So by the way, again, we have increase in the osmotic pressure if you add a solute to the solution. So why do we need to study osmotic pressure? Because osmotic pressure class is very important, especially that we are involved in like administration of substances directly to the vein or to the blood. Now, when you say osmotic pressure, it's the pressure required to stop, okay, to stop the flow of our water or our solvent. Or when you say, in simpler terms, pag sinabing osmotic pressure, it's the pressure required to stop osmosis. So what do you mean by osmosis? Remember that osmosis is the movement of our solvent, mostly atong solvent kay water, it's the movement from a region of higher to lower solute concentration. So mag-move siya. Now, if you administer solutions, there will be effects. Like, pag ang i-administer natin is an isotonic solution. When you say isotonic solution, it's a solution with the same osmotic pressure with that of our blood, or naa siya similar na solute content with our blood. So kung i-administer nimo siya, normally, equal lang yung magiging movement ng ating water. Dili siya magkaroon og effect with the red blood cells kasi equal yung solute content sa inside ng cell and the outside. So dili na siya painful for the patient and walay effect on his or her own red blood cells. However, if you administer a hypotonic solution just like water, kasi water does not really contain salt, so dili siya pantay ang magiging salt content between the inside of the red blood cells and the outside environment. Therefore, there will be osmosis here. Mag-osmosis siya ang liquid or ang solvent outside the cell. Baliktad. Ang solvent or ang water na outside the cell will go inside kasi mas daghan og solute dinhi, making the red blood cells swell, and then after that, mag-burst. So, as a medical professional, we need to know that we are not allowed to administer hypotonic solutions if not necessary. Okay? There will be times na mag-administer tayo ng um, hypotonic solutions, pero case-to-case basis yan siya sa ating patients. Most of the time, we administer isotonic solutions. That's the plain NSS, the normal saline solution, or the 0.9% NaCl solution. Kasi our blood class contains 0.9% sodium chloride also. So, na siya ang isotonic with blood. And then the last one, we have the hypertonic solution, which is a concentrated solution, meaning daghan kaayo siya og solute. So when you administer that intravenously to the patient, it means that the blood of the patient will be concentrated also with the solute, and then there will be osmosis. Kasi concentrated sa labas, the water inside the red blood cells will go out, mag-undergo siya og osmosis going outside, and that will result to the shrinking of the cell. And it will also die pag mag-shrink. So that's how important osmosis is. Before tayo go on with the computation, do you have questions about the colligative properties? Kasi this is still included sa inyong midterm exam class. Any questions? Alin dito yung hindi naintindihan kay balik ko na to og discuss. Na? Okay, so kung wala, let us continue. Na class, the law that governs the osmosis is called the Van Hoff's law. Again, it's Van Hoff's law. Ang katong sa vapor pressure, di ba, it's the Raoult's law. This time, it's the Van Hoff's law. And then we use this formula, pi equals MRT. So sa mathematics, you know that pi is 3.15, but for chemistry, pi is the osmotic pressure. Okay, do not forget that pi is the osmotic pressure. So capital letter M now is molarity. So this is different from the vapor pressure and the boiling point ha, kasi sa vapor pressure and the boiling point, it's small letter M. It refers to the molality. It's still the concentration of the solution, but it's the molality. This time, it's capital letter M, molarity na siya. And then R is the gas constant. The constant ha, so pag constant, hindi yan siya nagbabago. Now, what is the gas constant? It's 0.08206 liter ATM over mole K. So that's the unit of the gas constant. 0.08206 liter ATM. ATM is the unit for pressure or atmospheric pressure over mole. So we have mole here, mole, and then K class is Kelvin. Okay? So the temperature should be in Kelvin before you can compute for the osmotic pressure of our solution. So T, capital T is the temperature. Do not forget that you have to convert it first to Kelvin if hindi naka-Kelvin yung given. So please take note of the gas constant kasi hindi ko siya nilagay sa aking PowerPoint. 0.08206 liter ATM per mole K. Okay? Questions before problem number 1? Again, osmotic pressure is the pressure required to stop osmosis ha, para dili mag-flow ang solvent. So problem number 1, what is the osmotic pressure in ATM of a 0.30 molar solution of glucose in water? that is used for intravenous infusion at body temperature. Our body temperature class is 37 degrees Celsius. Sige, let's try to solve this. Wait lang, ha? Okay, so what is our formula again? Pi equals MRT. Let's see if the given ay complete. So pi class is the, again, osmotic pressure. Pi is again the osmotic pressure. It's the unknown in the problem. That is what is asked in the problem. Capital letter M is the molarity. So that is given. That's 0.30 m, or we can use the mole over liter for easy cancellation of the units. And then R again is the gas constant. Let me write it here. 0.08206 liter ATM per mole. Okay. Ayan. And the temperature now is 37 degrees Celsius. Before tayo mag-compute, I told you a while ago that the temperature should be in Kelvin before moving on with the computation. Now, how do we convert degrees Celsius to Kelvin? Anyone here knows how to convert degrees Celsius to Kelvin? I'll wait. How do we convert this one? Okay, very good. You have to add. So to compute the Kelvin, you just have the degree Celsius, mag-add ka lang ng 273. Okay? So mag-add muna tayo para Kelvin na yung ating temperature. So we have here 37 degrees Celsius plus 273. So 37 plus 273, it's 310 Kelvin. Okay, 310 Kelvin. So, kompleto na yung ating given. We can now proceed with the computation of the osmotic pressure. It's we have the M 0.30. Remember, gamitin natin yung moles per liter so that we can cancel the unit easily. And then our gas constant is 0.08206 liter ATM. And then the temperature now, we have converted it to Kelvin. So 310 Kelvin. So diretso lang ni siya class. I-multiply lang natin sila lahat. Or we can cancel, sorry. Wala din ako na dayon ang units sa gas constant. Kompletuhin na to. Mole. Okay, and then this is 310 Kelvin. So makancel ang mole, ang liter also naman ni sa baba, kanina sa taas, so you can cancel that. And then the Kelvin also cancel. So ang take note, ang maiwan na unit is in ATM. So that's the unit of pressure. Remember that we are computing for the osmotic pressure. So the answer here, 0.30 times 0.08206 times 310. 2 decimal places, the osmotic pressure for this solution of glucose in water that is to be injected sa sa body sa patient at 37 degrees Celsius is, sorry. Yan. It's 7.63 ATM. This is the correct answer. 7.63 ATM. Questions, class? Sa problem number 1. Wala? Sige. So let's move on sa problem number 2. You read the problem, you analyze it, and then you try to solve, and then PM me your answer. The first 5 will also get additional points sa exam. Okay? So I will wait for your answer. You just follow the formula, but this time, just like yesterday, this is looking for the molar mass of hemoglobin. Sige, I will wait. The first 5 will have additional points sa exam. Points ha, kay medyo lisod man ni. So, points. Ay, okay. Sorry. Yeah, you have to convert factor to ATM. Now, what is our conversion factor? Sa isa ka ATM, atmospheric pressure na kay 760 millimeters of mercury, and 760 millimeters of mercury is equivalent to 760 torr also, which means sa isa ka ATM na kay 760 torr. That's the conversion factor. Okay? I'll be waiting for your answers. Inom lang ko tubig. I'll be back. Osmotic pressure of a solution with 5 grams glucose dissolved in 2 liters of pure water to be injected through IV infusion at body temperature. So kamo na sad mag-solve, and then i-send ninyo as private message sa akin. So this time, we are looking for the osmotic pressure ng ating solution containing 5 grams of glucose. Dissolved siya in 2 liters of pure water. This is to be injected IV also, intravenous infusion at body temperature. Our body temperature class is most likely 37 degrees Celsius. So, chemical formula for our glucose, it's C6H12O6. Let me check it. C6H12O6. Yeah, C6H12O6. Okay, I'll wait also for your answers. Kana class? Kanilang? Pat pa lang ni katao. Let's wait for another one. Okay, so let's answer the third problem for the osmotic pressure. Let's see if we have the same answer. Sige. So, we are asked to compute for the osmotic pressure of our solution. It contains 5 grams of glucose. Remember, glucose is C6H12O6. It is dissolved in 2 liters of pure water. This is to be injected via intravenous infusion at body temperature, or body temp is 37 degrees Celsius. So this is pi equals MRT. We will be computing for the pi. Now, first, we have to look for the molarity. So, molarity is not given in the problem, but by looking at it, you can actually compute for the molarity. Sa molarity class, we have here molarity is equal to the moles of our substance per liter of solution. So, ang liter, given siya, it's 2 liters. We just have to compute for the moles. So for the moles, remember always this formula, weight is divided by the molecular weight. So the weight is given, it's 5 grams. And for the molecular weight, we can actually compute for the molecular weight of glucose. We have here C6H12O6. C6H12O6. Ayan, this is 12, 1, and 16. So let's see what is the molecular weight of our glucose. 6 times 12 is 72. This is 12. 16 times 6 is 96. So 72 plus 12 plus 96 is 180 grams per mole. So this is 180 grams per mole. Makancel ang grams. So 5 divided by 180 is 0.0277 moles. Okay? So, naano tayo moles, we can proceed with the computation of the molarity. Ayan. And then, sige, 0.027777777 divided by 2. The molarity is 0.013888 moles per liter. So, mo na siya itong gamiton dire sa computation sa atuang osmotic pressure. Okay. Moles per liter. And then our gas constant is 0.206 liter ATM per mole. Okay. And wait, sa baba na lang ha, kay dili na siya makasya. Okay. And then for the temperature, it's 37 degrees Celsius. We just have to convert it into Kelvin. So it's degrees Celsius plus 273. So this is 37 plus 273. Ilan na siya class? 37 plus 273 is 310 Kelvin. So sa baba na lang please kay di makasya. So let's cancel the units. Moles, liter also. And then, it's Kelvin. Kelvin siya. Karida yung liters. So cancel po ang Kelvin. So, ang maiwan na unit is ATM. Let's try to solve. So 0.01388 times 0.08206 times 310. 2 decimal places. The osmotic pressure here is 0.35 APM. Okay, it's 0.35 APM. Okay, let's list down. Ipasa ko lang sa section na yung answer, ha? Sige. So, who is pinakaunang nag-pass? We have number 1, Musa. Number 2, Agleham. Napuno na ni Diri Eden. Nanubra na ni grado sa kwara. Abot na siguro 100. Okay. And then we have Montilla. And 1, 2, 3. Kulang doha. Angkoga. And the last one, we have Esmalin. 1, 2, 3, 4, 5. Yeah. Taman kay Esmalin. Asa nakuha ang 0.08? Asa napit ang 0.08? The 0.08206 is the gas constant. So constant na siya ha. Wala na nagabago ang iyahang value. Module na siya. Pag R, the gas constant, it's 0.08206 liter ATM per mole. Okay. So gihatag na ko na siya kagaina before ta nag-start og compute. Okay? So let's have another one para tong uban na wala pa dinhi. See light points. Okay. Wait lang, let me clear the writing sa screen, and then the next one will be I'll be writing the problem on the screen. So the next na mga problems na siya, dili lang siya solely for osmotic pressure ha. So it can be sa vapor pressure, pwede pod sa boiling point, freezing point. Depende sa kung isulat. Mm. Mm. Wait lang. Erase, erase. Hmm? Ano siya nilito? Ayan. Okay, that's it. What is the boiling point of a solution containing 3 grams of glucose dissolved in 500 grams of water? Okay, I'll wait for your answers again. Awesome, Eden. Uy. Sige, go. Let's wait for the others. Be careful with the rounding off ha. Sa final answer na lang mag-round off. Kasi gamay lang ligas ani sa decimal places niya. Wala na o may maghabol pa? Okay, mag-start na tag-answer. Sige, let's wait. Yan. Sige. Let's answer this. This is for the boiling point class. So we will be computing for the boiling point of our solution if it contains 3 grams of glucose and then dissolved sa 500 grams na water. So remember our formula. Change in the boiling point is equal to kBm. Now, ato ang solvent diri kay water. We can go back to the table to see if what is the Kb of water. We know that it boils at 100 degrees Celsius, but the Kb here is 0.512. Okay? Again, it's 0.512. So, it's 0.512 degrees Celsius per molality or molal. Now, how about the molality? We can actually compute for the molality if we use the given. We have the 3 grams of glucose and then dissolved siya in 500 grams of water. So remember that molality is the moles of our solute divided by kilograms of our solvent. So sa moles ng ating solute, we have 3 grams of glucose there. How do we compute for the moles? This is weight over the molecular weight. So the given is 3 grams. And for glucose class, sa previous nga problem, ato ang gi-solve ang molecular weight ni glucose, diba? It's 180 grams per mole. So 6 times 12 plus 12 times 1 and 6 times 16. So that's a total of 180 grams per mole. So makancel ang grams, maiwan ka ang moles. So 3 divided by 180 is 0.0166 666 kulang isa. 6. Okay, moles. So naana tayo moles again. Ayan. And then for the kilograms class, grams ang given, so you just have to convert that into kilograms. So 500 grams, our conversion factor here is sa isang kilogram, meron kang 1,000 grams. So this is 0.5 kilograms. Mana siya itong gamiton dinhi in the computation of our molality. So this is 0.016666666 And 6 divided by 0.5. The answer is 0.3. 0.033. Okay. Ayan. Moles per kilogram or simply small letter M. That's na to sila. Okay. Ayan. So, muna siya ito ang gamiton din he. This is small letter M. Cancel. So, ang maiwan is degrees Celsius. So, times 0.512, it's 0.0170666 degrees Celsius. But we are not yet done because the question is not the change in temperature, but rather it is asking for the boiling point of the solution. Therefore, we need the second formula, which is the final boiling point is equal to the change in your boiling point plus the initial or the original boiling point. So the change here is 0.01706 degrees Celsius plus our solvent is water, and then we know that water boils at 100 degrees Celsius. So you just add this, it becomes 100.017066. Or we round this off to 2 decimal places. The correct answer, the final boiling point for this solution is 100.02 degrees Celsius. This is the correct answer for this problem. Okay? 100.02. So, let's wait. Asa pa nagsugod? So we have agleham again. Tagahan na namin agleham. Okay. And then we have Mecca. And then that's 2 already. And then we have Monesa. And yeah, tatlo lang. Only 3 got the correct answer. Eden, Mecca, and Monesa. 100.02. The rest answered 103.07. So what went wrong in the computation? Ano na abot siya? 103.7. Ayan. So questions class. May time na di ay. Yeah, it's 8:54 naman di ay. So I don't have much time left na. Questions class? Namali kag type, Janica. Sige. So you review class. Your exam is murag 80% computation. Daghan kayo computation ang inyuhang midterm na lecture exam. It's scheduled on Saturday. Saturday ba scheduled sa inyuhang exam? Let us check. So ang coverage is asa siya nagsugod sa stoichiometry. So gikan sa stoichiometry, and then we have the electrolytes, and then the last one we have colligative properties. So tatlong chapters class yung coverage ng ating midterm exam. 80 points all in all. And then mga 80% of that is solving. Ano sa schedule sa inyong exam again? It's on Monday pa, next week. Next week pa ang schedule sa inyong exam. That will be 4 to 5:30. So you prepare. You're allowed to use your periodic table and then your calculator. And then prepare also for extra sheets of paper kasi since merong mga solving, kailangan ito ng paper for your solutions. Okay?